So next, take a look at issues that are related to input validation. So when we ever get like input from a user, we should be validating that input in whatever way that we can. So we should be like sanitizing, make sure that they don't input anything that's vulnerable or that could potentially lead to an exploit, essentially. So there are a few different types of input validation errors that can occur inside of Android apps. So we're going to take a look at a few common ones right now. So for the first set of input validations, they have to do with database validation. So when we're inputting things into this, we can see that, for instance, if I put in user here and press search, we'll see user not found. So you can see it will echo back whatever our value that's inputted is, and it will tell us that it's not found, or it will echo back the details of the user, presumably, if we input one that is found. If we're looking for the code that's related to this, we can go into SQL injection activity, and this will show us exactly what's going on. So as you can see here, it's doing a raw query against the database, and this is the query that's actually happening. And you can actually see that when it encounters an exception, it's going to actually show the exception in the error log. So this means that if we go into our logcat, which I've got open here in Android Studio, when I input in something invalid, so for instance, a very good example of this for testing purposes would be like a single quote. A single quote is a piece of SQL syntax. If it's interpreted like code, it should cause an error. You'll see when I search this, we've got this error here that says unrecognized token. This tells us that we're interpreting that token as code rather than interpreting it as an input. So this means immediately to me that this is vulnerable to SQL injection. So let's take a look at how we can craft SQL injection with this. We have access to the query here. And again, this isn't an uncommon thing. If we can decompile the code, we can gain access to the queries. And as you can see, our input is going in right here. So it comes in right in the middle here, right in between two single quotes. What that tells me is that if I can end the single quote and then input something that's always true, and then maybe put a comment at the end, that will allow me to execute where user equals blank, or say 1 equals 1, which is always true, which will return to me the whole database back. So let's take a look at exactly what that looks like. If I put the closing quote here, this will close the user's input, and then we'll say or 1 equals 1. And then we could put a comment. So those two dashes at the end is a comment, or 1 equals 1 is something that's always true. And the closing single quote would close off this starting quote here. So it'd be user equals blank, or 1 equals 1. And then we comment so that this end brace here, or this end single quote here, isn't interpreted as code. And in doing this, it will give us a valid query. And that valid query is going to return to us all of the contents inside of the database. So you see when I click search here, it exposes the whole database credentials, right? So you can see that this is an example of being able to leak information from a database using an invalidated input. So SQL injections are a very common type of input validation error that happens in a lot of different instances. So this would be one example, and this is one thing that you're always able to sort of test. Now, not always will you get the errors actually printing into the log. It's actually quite rare that someone would give you that. However, again, if you just sort of like search for raw query or query in general, you should be able to find instances where this sort of thing happens. So this is one type of input validation that's relatively common. I'm going to show you another type of input validation that is rather interesting and a little bit different. So with this one here, you see that we can type in a URL to view. So if I put in like google.ca, for instance, if I press view, you see it brings up the web page for Google. So this is just like a simple web browser, and if we go into the code of it, we can get a bit of a better idea of what's actually happening. So you see here, we have the input validation scheme. You see that it just does a load URL. Now, on the surface, this probably looks quite innocent because load URL would imply to us that we're just loading any sort of, web page URL. However, the interesting point here is that in Android, we actually treat files as URLs as well. So we can actually access files on the system using the URL path of them. So for instance, you could do something like this. You could say file, you go colon, and then you put 3 backslashes, and then you put in the path to the file. So we'll say data, for instance. I'm just going to pick a file that I know exists. So this is inside of the data files that we were looking at. We were taking a look at insecure storage. And we know that there's one here called shakar.c seam.diva_preferences.xml. So you can see here I've just put in the whole path of the file itself. And oh, it just crashed there. Sorry, let's try that one more time. Not sure why it crashed there. We'll give this another try. Yeah, there are some instances where this app may crash on you. It's not overly common, but it could be from some other testing that I was doing related to this app for input validation. But let's go ahead and try this, diva preferences.xml. You'll see when I click on view here, it actually displays the file below here. So if you remember, this is the file that we created in the improper storage. So this shows us how we can actually access that storage without necessarily even having root permissions. If we happen to know this path, which it wouldn't be unreasonable for us to know it, if we have a rooted device, we can find it very easily, or we can find it through the code. We can actually access it if there's ever like a browser that happens to take in these file paths, for instance. So this is a very critical vulnerability because it allows for information leaks, and we can get to really any sort of file on the system utilizing this. And we might even be able to access this from other applications if it has like a provider that allows us to launch this activity maybe, right? So this is a very common and critical vulnerability. So this is another type of input validation that you can look out for. Something is parsed like a web page utilizing this whole, this load URL. It's very possible that we'll be able to load internal URLs, which are actually passed to files. So this is another type of common input validation. Again, so we have databases and we have URL loading. The third type of input validation is a little bit different, and the way that it essentially works is by calling external libraries. So what you'll see here is this uses the DJNI class rather. And you see that it uses a very specific piece, initiate launch sequence. So what's interesting about this is that if we go to this input validation 3, what we're able to do is we're able to put in some inputs and attempt to get it to launch. And you'll see it gets us access denied in these cases. What we're actually able to do with this is, since it's loading a shared object library, it means that it's probably written in C or C++. C and C++ are relatively infamous for buffer overflows. If you can input something way too big into this input, we may be able to get it to overflow. So for instance, if I just type in like a whole bunch of A's and I push the red button, you'll see the application crashes. When an application crashes like that, it tells us that there could potentially be a problem, and it might be related to buffer overflow. If we want to get a bit more detail, we can actually go back into the logcat logs, and I'm assuming it's probably going to give us some information inside of here when we try to crash this. So let's try this again. Yeah, you'll see there we got the whole like sort of dump. So this right here is what we would call a stack trace, essentially. So you can see it gives us a lot of information here. The main things that you want to get here is that you see the parts of the stack that we've actually accessed. So we can see that we're actually overflowing the stack here. And you can see that it's giving us some errors related to that. Now, what happens here is if we can actually specially craft our input, we may be able to get the device to execute code, which may be able to get us access to execute code under the permissions of the application itself. And this would be an extremely critical vulnerability. This is like a CVS 10.0, but even just getting the stack overflow to happen creates a very critical vulnerability as well. So oftentimes, like with Java, it's not very common to see a stack overflow, but if you're using C, C++ libraries or languages similar to that where you have to do memory management, this is definitely something that's in the possibilities. So if you're able to find something like this, it's an extremely critical vulnerability. And again, the things that you want to look out for this is any sort of class that is loading a shared object. So this DJNI class, we talked about this earlier in this series, but you see that it has like this load library, right? Anytime you see that load library, you might be loading SO files, which are typically C, C++. Now, one other thing that I will note about this is that when we ran strings against this library, one of the strings that came up was strcpy, or string copy. String copy is one of those C functions that is infamous for buffer overflows if things aren't allocated properly. So those are the sort of instances where we can actually utilize strings to see what kind of functions might be getting called. So that reveals to us, the function that's getting called, which is strcpy or string copy, right? So, and we can see that when that is used, it seems like it's causing the buffer overflow. So it seems like that string copy is what's causing that sort of problem. To actually get remote code execution is a fairly more complex topic. It won't be one that we'll talk about in this, but I wanted to demonstrate how you might be able to identify those sort of problems in an Android application to be able to report them. Because again, even just finding a buffer overflow like that is a critical vulnerability. So this gives you an idea of a few different types of input validations that might commonly be found in Android applications. So any of these issues in general are very critical because they mostly allow you to access things you shouldn't be able to, or potentially do remote code execution. So they're all very critical vulnerabilities and all ones that you should be able to relatively easily find if they do exist in an application. So this gives you some of the fundamentals to be able to locate those.